So in this video, we are going to introduce the high-level structure of the IRgen, which is something you're going to implement as a homework too. So this is our model solution for IRgen, which is consisting of only 2,000 lines of code. And let's begin. So it is not so short. It is quite lengthy, but most of the code is just the boilerplate that is necessary to deal with the many constructs of the C languages. So this is the IRgen. So we are going to first define the error type. That is the IRgen error here. So we designed this detailed IRgen error type because when something is wrong, we need to debug it, and in order to do it easily, we need very detailed error messages. So we put kind of very detailed information inside this type so that we can easily debug based on these error types. So it is going to have the code that is invoking an error, and also we are going to put the messages that is defined here, and the messages are either some specific reasons why the IRgen is detecting an error. In other words, the given program is wrong, or it is ill-typed. For example, something is redefined, or function is required, but something else is given, or we need to merge two data types, but they are not conflicting with each other, blah blah. And we have a catch-all cases that is only describing a message that is used for the rest of the cases that is not specifically listed here. Okay, so now this is the main structure that is actually translating the C to IR. That is consisting of the declarations that is defined so far and the type defs that is declared so far. So in the C program, there are many declarations, and in addition, there are type defs. For example, if the program is int A, then new type. We can do new type B, and this new type is actually integer, and we need to remember that new type is actually an integer. So that is this type defs is actually storing the kind of information. Okay, and given this IRgen, that is the declarations and type defs that are declared so far, we are going to continue to translate the rest of the file as follows. So this is just a boilerplate code for translating the types, and this is actually the actual mid of the translation. So as we saw in the previous video, we are going to walk through or iterate through each declaration inside the translation unit here. So for each external declaration in the C source program, we are going to deal with each of them. And if it is a declaration, we are going to call a function that is named add declaration. And if it is a static assertion, then we are just going to bail out because there is no such a case in our supported C programs. And if it is a function definition, we are going to add a function definition here. And at the end of the day, we are going to move the self-decals that was stored in here out of it, and we are just going to return it. So in the IR, we don't have type defs because that will be resolved. All type defs, type definitions will be resolved to the concrete types, but declarations should remain in the resulting IR. So we are going to pop it and and just return it here. So the main meat of the translation is these two functions: add declarations and add function definitions. So this is a little bit more involved because it is going to deal with all such details like control flows and symbol tables and etc. etc. So in this video, we are just going to look through this add declaration function. This is declared here. So this the job of this function is that it is given a declaration, and it is going to just transform self by adding a declaration to self.declaration or type dfs, and or if it is buggy, it is just going to return an error. Oh, something is wrong in this translation. I mean, something is wrong in the source program for this reason. So I'm going to stop here. So it is perfectly okay if the given C program is actually wrong because we are not going to test such cases. So yeah, so this is the first thing to do. There is a function that is already defined in the skeleton code, so that you don't need to implement again. That is try from AST declaration specifiers. So this declaration is a very complex object that is consisting of many things, and we're just going to translate what is called specifiers. So let's see what's going on there in this type. Try from AST declaration specifiers. So there is there's no comment here, but you can just memorize it. It is specifiers, and you're going to translate it using the skeleton code. And now you're going to use this D type. So you're from this AST specifiers, you're going to get the D type, and you're going to also get a Boolean value that is indicating whether it is a type df or not. So far so good. And so this is just declarators. So let me briefly explain what is specifier and what is declarator. So let's say that we have a code like int a, b. Then this is specifier basically. Int is specifier, and declarators are a and b basically. So declarators are basically a list of something that is actually declared, and specifier is describing the type of the declaration. But what is more involved, what is becoming more interesting about this is that if we have an asterisk here, then if you already know about C, you can see that this asterisk is affecting only A but not B. So A is declared as a pointer to integer, but B is declared as a simple integer. B is not a pointer. Only A is a pointer. So in this scene, integer alone is the specifier. But on the other hand, this asterisk A and B are the declarators. The declarators is the list of two things. The first thing is pointer to int A, and the last thing is just B. So in this code, it's actually trying to deal with such a declaration one by one by iterating through the declarators, and it is going to apply the decorator like this. I mean this ampersand the pointer is applied using the function with AST declarator that is already defined in the skeleton code. And yeah. And after this declaration, we are going to resolve the type dfs. So if the code is like this, if the code is type df integer and tt and tt, then at this point of time we are going to resolve that, oh, we are going to declare a pointer to tt. But tt is not a concrete type, so we are going to resolve the type dfs here using the type dfs that was declared so far. So at this point of time, now tt is gone, and now we only have a pointer to integer. And now if it is type df, then we are going to declare another type df entry here, like this. So this entry is a very useful API of the hash map that is extensively used in this compiler. Actually, we don't. I mean, this entry API is really versatile in finding and inserting and deleting an entry inside the hash map. So I strongly encourage you to look into the documentation and what's going on there with the entry API of the hash map in Rust. So we freely use hash maps, even though hash map is not that efficient in some cases, because we want to focus on the algorithms and dealing with this, basically language engineering, instead of optimizing the low-level codes. So that will be dealt with in later courses. And we're going to freely use hash maps or hash tables, hash sets or vectors or any other data structures that is already provided in the standard library of Rust. That can be inefficient for some times, but we don't care. As far as the result is okay, I'm done. I'm okay with that. And there's some strange logic that so this is basically, you're going to insert into the name that is being declared with the data type that is resolved here. So if this is the type df, you're going to add that into the entry. And the strange thing of the C is that if there are two type dfs with the same name, it is okay. But if you have a different entity with the same name, then it is not okay. So it is just checking that. So it is checking that if it is the name we are going to use as a type df is already declared, then we are going to check if the types are the same. And if it is so, okay. But if it is not, then we are going to return some error. So that is following the behavior of the C compilers, existing C and C compilers, basically. Now the type df case is done, and let's move on to the variable declaration case. And here we are going to create a new declaration based on the types we just calculated so far. So this is the type we calculated so far, and we also provided the helper function that is creating a declaration based on the D type. So you can just use it. And after this, we are going to deal with some initializers. So if the declaration is like this, so we need to deal with this initializer that is initializing the variable at the beginning of the program. So even at the beginning of the program, A0 should be 0 and A1 should be 1. So if there exists initializer, then we are going to deal with it and actually put it in the IR as well. So this is basically processing the initializer. So you can use those functions that is already provided in the skeleton code. So please open the documentation and read it very extensively, so that many of the functionalities are already implemented in the skeleton code. So after doing so, we are going to actually inspect the declaration. And okay, if there is an initializer, then it is going to put the value to the IR's declaration. And if it is a function, it is a buggy. You cannot initialize a function in this way. A function cannot be initialized in this way. Okay, at the end of the day, we are going to add the declaration to the name that was given in this function. And in this addDecl function, it is going to actually add this declaration to the inner inner declarations here. But if the same name is already taken by an earlier declaration, it is going to be an error. And I mean, no, it is not the case. Okay, let me try again. So if there was already the name was not already taken, you just put it. But otherwise, you have to see if it is comparable. So let's see like this. So in C, strangely, it is allowed to declare the same thing twice. Right. So basically, this is checking the situation, and if it is so, it is going to be okay. But it is not. It is going to be not okay, and just return an IRgen error. That means a compiler error. Your source code is wrong, and I give up in compiling your source program. Okay, so that is pretty much everything about adding a variable declaration inside the IRgen. And in the next video, we are going to discuss how to translate a function definition and how to put a translated function definition into the generated IR.